Alright, so first thing we're going to do is we're going to wipe down the bench with 10% bleach, just to get rid of any bad molecules or any DNA that may be left over from the previous labs. And then we're going to label our tubes. So these are reaction tubes. They have a capacity of 0.2 milliliters or 200 microliters inside of them. These are the tubes where the reaction is going to actually take place. However, we're going to first create a master mix where we put all the components that we need together, and then we individually aliquot into each tube, and then in each tube we're going to put the specific template. So the first thing you're going to do is you're going to label them. You're going to have plus, minus. Plus, we have some we have DNA from Pectobacterium. Our plus is going to be our positive control. Minus, we're going to put DNA from, well, not DNA, but we're going to put a colony of E. coli inside your minus. That'll be your negative control. So the primers that we're using are going to specifically target Pectobacterium. It's going to be a gene that is specific to Pectobacterium. So we should not get a product with E. coli. And we're also going to be putting 2 of your colonies that you guys have. If you don't have 2, you can just do 1 2 times. And if you guys have isolated Pectobacterium, then you should get a product. And this will be the way we definitely ascertain, with more confidence whether you actually managed to isolate it or not. So let's get to the mix. The master mix is what we call it. We have behind me, the things necessary for just 1 reaction. However, I want to do 4 reactions because we've got 4 here. So I could just multiply everything up by 4 and do the math in my head. Or what I recommend you do is you just make a table and come to class so you already know what to pipette into what. And that's what I'm going to do. So the first things first, we need water. You should have your tube labeled water, and you should have your tube labeled mix. That's going to be your master mix. We need 160 microliters of water. So which pipette are we going to use for 160 microliters? The P200, right. And what should the window say when we set it to 160? Just 160, yeah. 160, 160. For the P200, we use these yellow pipette tips, or yellow box. Again, when using a pipette, push down to get any air out of it. Put the tip inside the water tube. Slowly release the plunger. And then when you put everything back, you press on the plunger into your master mix, and then you hit the second stop as well. So there's 1 stop and then 2 stops. That second stop again is just going to give it a little extra puff of air. So once you have that, you should be putting all of your trash into this biohazard. And you can do that with this button on the back. So 160 microliters of water. Next we do 20 microliters of the 10x reaction buffer. So which pipette am I going to use for 20 microliters? Yeah, you can either use the P100 or the P200, or even the P20. So for this one you got options, depending on what you have at your table. Me, I have a P100, so I'm going to set it to 020 to get 20 microliters. I'm going to get 20 microliters of the buffer. Again, just press the plunger to the first stop, slowly release it. Mix the buffer and go to the second stop and pull. When you go to the second stop, you want to pull the pipette tip. Yes, these tips don't go with this pipette. And then you're also going to do 4 microliters of the DNTPs, the forward primer and the reverse primer, and the polymerase. So let me just do that quickly, since they're all going to be the same. For this one, I'll be using a P10. Oh, and it's important that you don't mix up the pipette tips as well. So once you put a pipette tip into some reagent, you can put it back into the mix and then mix it, but you can't reuse it. So make sure you're using new tips each time. So first I'll add the DNTPs, 4 microliters. Mix it. If you take notes, you may want to put a check mark next to each reagent that you put so you don't forget what part you're at. Or you can just close the cap once you're finished with it. Then the forward primer. The order of the primers doesn't matter. What's important is that you always put the enzyme last, because the enzyme can either be in its storage form, which is in glycerol, or it can be in its should be in its active form, we call it, which is when the solution is ready to go, in that it already has the buffer. The buffer is the important part for the enzyme, and then the water as well, so that the buffer is at the right concentration. And normally we do all of this on ice as well to keep all the reagents cold. Otherwise the heat starts to degrade the enzymes and stuff. Alright, so I should have about 200 microliters of water in here. Excuse me, of the solution. Next, we need to split up the 200 microliters evenly between the 4 different reaction tubes. So how much are we going to put into each tube? 50 microliters, right. For this part, you do not need to change pipette tips when you're going back and forth from the mix to the reaction tube. But during other parts you will have to. So you can take the strip off, lift it up, and make sure you have them all labeled as well. And then it's just simple as putting 50 microliters into each reaction. And you should have sufficient. If you run out of reagents, you probably skipped out on something, or you didn't put enough of something. Oh, I messed up. We're supposed to only put 48 microliters into each one, because we need to add the DNA. That's the last part of the reaction. So in here, they should all be about the same volume, or they should be the same volume. Into your plus, you're going to put a positive control. This is DNA from Pectobacterium. You only need to put 2 microliters of there. You also have a minus, so you can either use DNA from, use DNA from E. coli, which is labeled SAMP minus. What I want to show you guys though is how to do the colony part. So for this part, we're trying to keep the plates sterile so that the next labs can use them. So turn on your burner. You should all have either E. coli, or in this case it's going to be your bacteria that you isolated, right? You're going to sterilize your burner, your loop. Let it cool down a bit, touch the media, where nothing's growing, so you can melt the media, but it'll cool down the loop. And then you just barely touch your colony, whatever you want, because you really don't need much bacteria on it. And you're going to try to dip it into the water here. You need to ram it down there, unfortunately, because these two it's a little difficult. And hopefully you'll touch a little bit of the water. As long as you get the glob, try to get the glob like on the tip of the loop so that it can touch the water. And then just sterilize your loop, and you'll be done with that. So that's how you'll do that for 2 colonies that you are growing into 1 and 2. And then once we're done, just cap it and hand it to me, and we'll put it in the thermal cycler, and next week we'll analyze the results. One thing I forgot to mention though, after you mix everything into your master mix, make sure you flick the tube so that everything gets mixed around. Otherwise it's not going to be homogeneous and the reaction won't work. Alright, any questions? Alright, let's get to it then.